Histograms give us a quick look at the shape of distributions, especially with the use of technology. I've opened a dataset of a number of population percentage facts per U.S. state. I can easily create a histogram for any of the variables to get the shape and a few other data descriptors by inspection. So we've got our state column over here, our percent of foreign-born citizens in that state, our percentage of people under 5 years of age, our percent of people under 8. We're going to make a histogram for each of these. Let's start with the percent of foreign-born citizens. I go to Graph, Histogram, click the variable I want, percent of foreign-born citizens, and click Compute here at the bottom. And voila, I've got my histogram. And immediately screaming at me is a skewed right distribution. I can see the tail is on the right. The mode is over here in the column as I highlight it. Between 2.5% and 5% of these 12 U.S. states have 2.5 to 5% are foreign-born citizens. As we move out, some other factors that we want to definitely take in is we see the title at the bottom. We knew that already from the data, but in case we had just been shown the histogram without the data, that would be important. We've got the percent of foreign-born citizens here. We've got the frequency on the left, so we can see that the frequency is scaled by 2. So we have 0, 2, 4, 6, 8, 10, 12. And the frequency represents the observational unit. So what are we observing? We're observing U.S. states. So that's why I said here at the in this bar, we can see that the mode was 2.5 to 5%. And that happened in 12. Along the x-axis, where the data lies, these are the actual percentages that are found from each state. So we can also see that the bin size isn't marked clearly here, but we can see that we've got from 0 to 5 is 2 bins. So half of that would be 2.5. So right in the middle here is 2.5. So our first bin covers percentages from 0%, including the 0% all the way up to 2.5%, but not including the 2.5. If you're at 2.5%, you're moving to the next bin. And then we have 5, 7.5, 10, 12.5. So my scale here is 2.5. So notice on the histogram, I can see the shape, like we said before, skewed right. And then my eye gets drawn and we kind of wonder, well, who has the biggest percentage of foreign-born citizens? I think some of us can guess. That percentage is 25%, somewhere between 25 and 27.5%. But from the histogram, we would never know. So the histogram sometimes loses some information from the data. We actually don't even know what the actual percentage is. And we do know that there was only one state. If you can see frequency there's only one state that had this range of foreign-born citizen percentages. We're going to sneak a look over to the data up here and see, hey, look, it's California. You probably weren't surprised, but it was actually 26.9. But again, important fact, can't get that information from the histogram unless you have the data set with it. So even though we do have technology and we could figure out a lot of calculations based on the data, I think it's very good practice for you to be able to just look at a histogram and note a couple of things that you can just do by inspecting or estimating. The first thing that my eye is drawn to, like we said before, is the shape. But once I get the shape down, the very next thing that my eye usually goes to is the mode. And like we said before, the mode is somewhere between 2.5% and 5%. Then from there, I know because of my shape being skewed right, my median will be probably, well, not probably, it will be to the right of the mode. And the cool thing about the median as a measure of center is that it literally means the data value right in the middle. So if we add all these frequencies, and we can see as we highlight here, the first bin, there are 3 states that have that a percentage in that range. In the next bin, there are 12 states in that range of 2.5 to 5% foreign-born citizens. Third bin, 11. Fourth bin, 8 states. 2 states that have a percentage between 10 and 12.5. 6 states. 3 states. 2 states. 2 states, and then 1 state each out here on the end. So if we add all these numbers, we'll know that that's actually 51. We know there are 50 states in the United States, but over here you look, there's District of Columbia that we have to think about. So there are 51 elements. If you add up all these frequencies, you'll see that that's the sum. So if we were to break 51 things into 2 equal groups, we would be breaking the groups into 25 and 25, and there'd be one value sitting in the middle, and that would be at the 26th spot. So we'd have 25 data values below and 25 data values above. Apologies. So by inspection, the median will be in the 26th spot, which is in this third bin, just on the edge of this third bin. We don't know exactly what the percentage is because we don't have that information in the histogram, but we know it's going to be somewhere right in here. The next measure of center, the mean, I know is going to be, because this is a skewed right distribution, the mean is going to be tugged to the right of the median. So I have a feeling the mean, these have some pretty extreme values out here. So I have a feeling if the median is here, the mean's going to get tugged a little bit more to the right. So somewhere between, somewhere around 10% probably. Now that was an estimate, what I just did. The mode and the median I found exactly, and I did that by inspection. The estimate, I'm kind of going, the mean's going to be somewhere to the right of the median. That's called estimation. The last thing that I think about when I look at a histogram is, or probably the penultimate thing I look at with a histogram, second to last thing, is the how the spread of the histogram is. So a lot of you know the minimum would be in this first bin here. So the minimum is somewhere between 0 and 2.5%. And the maximum is somewhere between 25 and 27.5%. So I'm just going to use the outer range, the outer edges of those minimums, since I don't know the values. And I'm going to estimate, I'm going to inspect and estimate together, because I can see that these are the ranges, but I've got 27.5 and subtract 0 on the low minimum end, and I get a range of 27.5%. Now, that's a pretty, that's as extreme a range as we're going to get, because we're taking our extreme edges of the distribution to find the range. There's actually a slightly better measure of spread called the standard deviation, which is the average distance of each of the data values from the mean. And that measure of spread, I usually just estimate by taking the range and dividing by 4. This is called the range rule of thumb. So if I take 27.5 and I divide by 4, I'm going to get 6 and, what is that, 6.82, something like that. We better check that stat. Oh, I've got a calculator right here. That would have been nice. 27.5 divided by 4. So roughly the standard deviation will be 6.875. So those are the 3 big things that I look for anytime I look at a histogram: the shape, the center, and then the spread, how spread out it is. Then at the very end, I look for anything that might be of interest. And the only thing that I can see of interest here is how we rise up in the distribution. And then there's this dip down here, so it almost gives it a kind of bimodal feel. So I'm thinking that maybe there might be something different about these states out here than there is, about these states over in this region. So I'm wondering if this might have a little bimodal property to it, maybe separating the more populous states from the more rural states. Now let's see how good I did at estimating. If I go into the histogram and push edit, I can have some markers here with the mean and the median. But again, sometimes we'll just ask you to eyeball it, so be able to do both. And here I can see that my median, look, it's in that third class like I thought it was. The median is, if I hover over it, 7.1%. And the mean is close to the 10% that we said that we estimated. And that mean is actually 9.3%. So we did a good job of estimating the mean and the median. If you want to go even further, we can look at the summary stats. And if we look again, percent of foreign-born citizens, and I look at N is how many states I looked at. I want the mean. I want the standard deviation. I'll take the range and the median there as well. And we can even, since we got them, the min and the max, we'll stop there right now. If I push compute, now I get all those values. Histogram, a percent. So here's the histogram, and here's the stat summary. The mean was 9.33. The standard deviation was 6.1. Our standard deviation that we estimated was 6.875. So we had a little bigger range, but close enough. And the range was 25.3, and we had 27 something close. And the median, and the min, and the max. You get to see all those facts. But as long as you have the data. I'm going to let you try with the percent of people under 5 years of age. So pause the video, make a histogram, and get some, notice what the shape is, the mode, the median, the mean. Those are your measures of center. Estimate what you think those are. And then estimate from the histogram what you think the range and the standard deviation is. Now we're back. I hope you paused it. If you didn't, you're cheating. That's okay. Histogram. People under 5 years of age. Here's how I would do it. I look, I notice we've got a normal, roughly normal distribution. My eye does notice there's a little gap right here. So something weird happened between the percent, no states, actually not anything weird, but there were no states that had a percentage of 5-year-olds between 7.5 and 8%. But it's normal distribution. So that means when you're symmetric distribution, the mode and the median and the mean are all going to be roughly in the same location. So this bar of the mode, which is between 6% and 6.5%, that's going to be my estimate for the median. That's going to be my estimate for the mean. We could inspect, but we don't even need to with the symmetric distribution. The range, I can see here, the range is from 8.5 to 0. So my range is 8.5, which would give me an estimate standard deviation of 2.125. So roughly 2.13% is my estimate for standard deviation. Let's see how I did and go to the stat summary. I thought I was going to summary stats. There it is, columns, and people under 5 years of age. Let's see how our computations went. Not even computations. But see how fast we did that? So the mean was 6.04. It's in that bin that we said it was in. The standard deviation was 0.64. So we were quite a bit off with the standard deviation because it is a symmetric distribution. The standard deviation is going to be much less than usually what the range rule of thumb says. And then the range was 3.3%, which I don't understand that one. It shouldn't be that. So let's pause the video. Okay, so I'll admit I was a little freaked out by that range, but it again shows you how not knowing the actual values that are in these bins can really affect your estimates. Because I looked at the range, it was 3.3, and I had, the extreme values of about a range of 8. But notice that I did the min and max up here, and the minimum is just below the 5% here. So we have a bunch of percentages that are 4.7, 4.8, 4.9 in here, or 3 of them at least. And then, so 8, and then the highest one, the maximum, is actually exactly 8. So there are no values beyond 8. So that's going to mean we're basically looking at a range of 8 minus the upper bound here of 5. So again, I wouldn't have known that though if I didn't have the data sitting right next to me. So that's why our standard deviation estimate was so far off. So it's always better. These are the exact values that you get from StatCrunch. But if you didn't have technology, it's always good to be able to eyeball. What do you think the mean is? What do you think the standard deviation roughly is?